This is 3, 5, 24. Now we're looking at chapter 3, section 6, the chain rule. This rule is going to help you more than anything, because what this one looks at is if you had a function f of x, which is made up of a function within a function. And this is a composite function. The derivative of this, I'm going to just pretty much go through this and show you an example here that'll explain a lot of these things. The first thing you do is take the derivative of the outside function. That takes the derivative of the big part. Then you take a derivative of what's inside. Have we seen this before? Yes. The derivative of this is take the derivative of the outside, then the derivative of the inside. Here's an example real quick. Y equals 2x squared to the power 3. So what's the derivative going to be? First step is what? 3. 3 minus 1 is 2. That takes care of the outer function. Now the derivative of the inner function. What's the derivative of 2x squared? 4x. Multiply what you can. 3 times 4 is 12x. 2x squared squared. Which we can, we could have looked at another way, but that's the way you do it. Example 1 in your sheet. Three x squared plus 1 squared. So the derivative. What's the first step? Bring down the 2. So we have 2. Leave what's inside there. Leave it alone. So 2 minus 1 is 1. Next part. The derivative of the inside, which is 6x. That 1 goes to 0. So the derivative becomes 2 times 6 is 12x times 3x squared plus 1. And if we wanted to, since there's no exponent there, we can even distribute. If we use substitution, which a lot of times you may need to for simplicity purposes, the derivative is your first with respect to the u, and then the second with respect to the x. That's what this is really doing. So in our example here, we would say that u is equal to 3x squared plus 1. So we have y equals u squared. The derivative, well, we also have to find du. What's the derivative of u? 6x. So the derivative of u squared is what? 2u times du. So when we put the stuff together, we have 3x squared plus 1 times 6x, which is what we just did on top. We'll do some more of these. Actually, this is my example. Find that derivative. Using it though. For example, what would u be? Yeah, it's what's inside the parentheses. 2 cosine x minus 3 sine x. So what would du be? The derivative of cosine is what? Negative sine, so it's negative 2 sine x minus 3. Derivative of sine is cosine. So what we have here is u to the fourth. The derivative is 4u3 du. So u is 2 cosine x minus 3 sine x to the power 3 times du. Negative 2 sine x minus 3 cosine x. So the only thing you really do is just combine these two. I'd leave this one alone. So 4 times negative 2 is negative 8 sine x minus 12 cosine x. As far as you can go. You're looking at it weird.
So you don't count the negative numbers of the sign as a negative sign, and then so when you turn the graph go to the cosine.
For which from here from this one? Yeah, so that one's there. So the derivative of sine is what? And that negative still stay there. Because it's actually the coefficient, negative 3 times sine. Even if you did, okay, if you did negative sine x, what's the derivative of negative sine? Negative cosine. Yeah, so it really wouldn't matter. But yeah, to leave with coefficients. Example 2. It says an object moves along the x-axis. For time greater than or equal to 0 is given by the function Since it's an x-axis, it's got to be the cosine function. T squared plus 1. Find the velocity of the object. So this is the function of the object moving along. So therefore, this is the position function, which earlier we defined as S of t. How do we find the velocity? Take the derivative. So cosine of u is t squared plus 1. What's du? Two t. So the velocity, which is the first derivative of cosine is what? Negative sine u times du. So we have negative sine u is t squared plus 1 times 2t. Which becomes negative 2t sine t squared plus 1. Does anybody have trouble seeing it still? Or is it just takes practice? We have 4 or 5 more examples to do. Example 3. Outside, inside rule. This is what we've been doing. Take the derivative of the outer function times the derivative of the inner function. So I don't know why they decided to give it a whole topic of itself. Do they call this the outside inside rule? So example 3. Differentiate. What does differentiate mean? Find the derivative. Exactly. Very good. Find the derivative with respect to x. So this is what y equals. So y is equal to sine u. So what is u? X squared plus e of x. Then what's du? Two x plus e of x. So the derivative of sine is cosine u times du. Now we just plug them in there. Cosine x squared plus e to the x times 2x plus e to the x. There's your answer. As far as you can go. I mean, you could put that in front, but Example 4. See, this is where it would help. Before we do that one, let's do a simpler one. If I had e to the 5x, what is y prime? Because u is the 5x, du is 5. So we have EU du. That's the derivative. Which is we'll make this one easier. Y equals e to the power cosine of x. So u is what? Cosine x. So what's du? What's the derivative of cosine? Very good. Negative sine x. So the derivative of e is eu du. What? So we have e to the power cosine of x times negative sine x. There's your answer. You get negative sine x e to the power cosine x. Either way, you can write either way you want to. So far, so good. Are we getting better at this? What if you had to use the chain rule a couple of times? That's what this next part is. It says repeated use of the chain rule. So let's work out example 5 slowly. So we have g of t is equal to, well, I'm going to use g of x because I hate my t's. Tangent of 5 minus sine 2x. What is our u going to be? 5 minus sine 2x. So we have right now so our derivative, what's the derivative of tangent? Was it? Times du. So that's the easy part. Now comes the hard part because we have to do it again. The derivative of u, derivative of 5 is what? 0. It goes away. Now we have another one. It's minus sine u here is 2x. So du is 2. So we have sine of u, the derivative of sine is cosine, u du. makes it negative cosine 2x times 2, which makes it negative 2 cosine 2x. That's my du. That goes there. So the derivative is secant squared 5 minus sine 2x times negative 2 cosine 2x. Put that in front. Negative 2 cosine 2x secant squared 5 minus sine 2x. There's your derivative. The hardest part of that is keeping it all in order. There's a lot of writing. That's where your mistakes are going to happen. So make sure you have it compartmentalized or put it in compartments so that you know where everything is, where it belongs. The chain rule of a power function, let's look at example 6. Which this is stuff we've been doing already. The chain rule of a power function. Example 6. If y equals 5x cubed minus x to the 4th to the power 7, what is y prime? So again, we have u to the 7th. So we have 7 u to the 6th times du. See the derivative of the outside times derivative of the inside. So it becomes what? 7 5x cubed x to the 4th to the power 6 times the derivative of the inside. 5 times 3 is 15, x squared minus 4x cubed. And there's your answer. If you have any questions, please ask instead of trying to figure out yourself, because if there's no questions, I'll move on to the next one and you'll be falling further and further behind. So if you have a question, ask. It'll go much faster that way. Y equals 1 over 3x minus 2. Yes. You're right. You're right. I could multiply these out together. Yeah, I could. 7 times 15 is 105x squared minus 28x cubed. Right. I could do that. I believe so. Okay. That's why you have to do the homework and find out what the rules are. I mean, the homework does just that. It helps you realize how they want the answers in the test. That's why I don't answer questions when people ask on a test what format it's supposed to be. I said, well, go do your homework, find out. So u is 3x minus 2. With this one, since we have a 1 on top, we can rewrite this as 3x minus 2 to the power negative 1. U is inside there, 3x squared. Du is simply 3. So y prime would be bring down the power, negative 1, and subtract 1, which makes it negative 2, times the derivative of the inside. You never want a negative exponent as a final answer. So we have negative 1 times 3 is negative 3, and 3x minus 2 squared on the bottom. And there's your answer. Yes.
The second power is from, does he have to get rid of the negative two, right?
Well, no, the power negative 2, because here, when I rewrote this as an exponent, it's a negative 1 exponent. When you take a derivative, you subtract 1. So negative 1 minus 1 makes negative 2. And that negative 1 in front comes from that derivative. So the power function you should take out in front. Letter C. Y equals sine to the 5th x. This is the same as sine x to the 5th. So the derivative would be what? 5 sine x to the 4th times the derivative of sine is cosine. Which makes the answer 5 cosine x sine to the 4th x. E to the power radical 3x plus 1. So our u is radical 3x plus 1. What do we do with that? How can we rewrite that so we have a power? 3x to the power 1/2. Very good. So the derivative of u is 1/2 3x plus 1 to the power negative 1/2 times 3, which is on the inside. Which becomes that. The derivative goes EU du. So we have leave this alone. times the derivative, which is this. And there's your answer. If you want to simplify this whole thing, we have 3e 3x plus 1 over 2 3x plus 1 to make it look neater. Let me see. Number 8 not gonna be a problem. Number 9 not gonna be a problem. It's the same stuff we're dealing with. The only one we have a problem with is example 7, real quick, and I'll let y'all go. How would you take the derivative of absolute value of x? How would you define the absolute value of x? Algebraically, we could look at it this way. Because remember, absolute values make whatever number that's negative inside there makes it positive. When you square a negative number, it makes it positive, and when you square root it, it shrinks it back down to where it's supposed to be. So that's algebraically how we would do it. So now we take a derivative of this. So our u would be x squared. Du would be 2x. This would be u to the power 1/2. The derivative, 1/2 u subtract 1 makes it negative 1/2 times du. U is x squared, so it's square root of x squared times 2x. The x's cancel, the 2's cancel, so we have x over square root of x squared. What does square root of x squared equal? Absolute value of x. So there's the derivative of the absolute value function. Yeah, and you have to force yourself not to simplify x squared, square root of x squared. But I remember I used to do that also. So that's x. No, but we defined absolute value as x squared, square root of x squared. You have to keep it that way because then we go back to replace it. Everybody okay with that? If not, watch the video. And in number 8, example 8, I'll just set it up for you. You had y equals 1 over 1 minus 2x cubed. How would you rewrite that so we have a power? It'd be 1/3 if it was a cube root. Since it's on the bottom, the rule we have is in exponents. If you ever have a negative exponent, you just simply change the location of it. If it's on the bottom, we move it to the top. If it's the bottom, top move to the bottom. So since we're moving this one to the top, we have to change the sign. Then we take the derivative of this. -3, 1 minus 2x to the -4, because you subtract 1, times the derivative of the inside, which makes it negative, negative makes it positive, 6 over 1 minus 2x to the 4th. There. Whew. we did a big chunk there. All right, everybody, sorry I kept you so long. How many of you have classes now? Nobody has any classes? Oh, nobody has a class after? Oh, great. Because that means we can keep on going. No.